is to provide a general introduction to the PASA Soil Health Benchmark Study, to tell you about what we're trying to do with this project, how you can get involved, and as well as to share some new results that are coming out as we just now start to really dive in deeply to data we collected last fall and over the winter. So just by way of general overview, I always like to point out that PASA is a sustainable agricultural organization based in Pennsylvania and active throughout the region. But I think one of the neat things about our organization, one of our strengths, is that we don't have a real prescriptive definition of sustainable agriculture. In the 25-year history of the group, we've really tried to keep it an open and evolving conversation and as to what is sustainable agriculture. And so a few years ago, when we were developing our research program, we really wanted to develop kind of an outcome-based concept of sustainable agriculture, where we could look to things that we were measuring on working farms as benchmarks to know whether or not we were sustainable, or really more to the point, becoming more sustainable. And so in 2016, we did a series of surveys and focus groups with our farmers, and we asked them the question, if they were to measure the sustainability of their operations, what is it that they would like to measure? And this was some really interesting feedback. We found that pretty much across the board, as we talked to farmers across the state, different types of farms, different types of scales, we learned pretty consistently that our farmers were pointing to three things as kind of their top metrics of sustainability. So they were talking about, number one, financial viability, but then pretty much in the same breath telling us about soil health as just a fundamental and foundational aspect of agricultural sustainability. And then they also were very interested in the nutrient density of their products and wanting to make sure they were providing customers with the most nutritious food they could. And so this is all really interesting and exciting because these three variables, these three domains are very much interconnected. You need healthy soil to produce nutrient-dense food. I think particularly in the Northeast, where many farms are small and competing based on story and based on quality, nutrient-dense food is necessary for financial viability as well, and these things feed back into each other. So with that in mind, we set out to build protocols, to build research systems where we could work with our farmers to actively measure these dimensions on their farms. And so we're now 3 years into what we're calling our soil health benchmark study, getting some really interesting and valuable data together. We also have a financial benchmark study that we're in the second year of, primarily for vegetable farmers, but also hoping to expand that to other farm types, and would very much encourage folks to learn more about that. We have information up on our website and are working with farms across the state to benchmark finances. And we hope to sometime in the coming years to layer onto all this nutrient density testing and measuring and benchmarking. So really a lot of exciting work happening at PASA. Okay, but today we're going to focus on the soil health benchmark study, and I'm going to tell you how this works and what's involved. I thought I'd start by talking generally about the principles of soil health that the NRCS points to in a lot of their soil health work, and I think this is a really viable framework, valuable framework to thinking about soil health in terms of the basics, in terms of maximizing continuous living roots, in terms of minimizing disturbance, in terms of maximizing soil cover with residue and other materials, and in terms of maximizing biodiversity with crop rotations and integrating animals and so forth. And so these are pretty intuitive, easy to understand principles. The hard part comes in trying to figure out how to actually apply these into a real working farm and to get better at them year after year. And so really what our project is about, what the soil health benchmark study is about tracking how well farmers are doing with respect to these different principles, and then providing some real measurable outcomes in terms of the health of the actual soil. So how the project works is it's basically got two components. One, we do field soil sampling in a consistent and coordinated way across our participating farms. We choose 3 study fields on each participating farm, and we collect samples from each field in mid to late October of each year. And we send our samples to the Cornell Soil Health Lab, and I'll talk a little bit more about that. And then in the winter months, we work with all of the participating farmers to gather and organize some pretty detailed farm records in terms of what they're doing to manage soil health. And so this includes things like records on soil disturbance, whether that be from tillage operations or planting operations or running livestock across a field. We collect really detailed information on crop rotations, when crops and cover crops are planted, when they're terminated, and then really detailed records on soil amendments, how much and of what type of fertilizers and amendments are going on each field and each crop. Farmers are using all different kinds of systems to keep this data. We work with folks that send us Xerox copies from clipboards. Other folks will use spreadsheets that we've developed. And increasingly, we're working with farms to use an open source and free record-keeping platform called FarmOS, which can be pretty handy and pretty flexible for all types of farm record keeping on a lot of different types of farms. And we're actually offering free web hosting for this application for PASA farmer members. And we have a couple of webinars up on our website, pasafarming.org, that you can explore if you'd like more information about using FarmOS. But so the two pieces are the soil samples and then the farm records, so we can connect management and outcome. We also have some kind of citizen science hands-on add-ons that are kind of complements to these core parts. They're activities that farmers can do in the field on their own time to get more of a touch and feel for soil health. These include visual percent cover estimates of how cover crops are coming up and when, penetrometer readings for compaction, earthworm counts, and we also have this decomposition test we've been experimenting with, where you can look at the rate at which green teas and red teas, a high CNN material versus a low CNN material, decompose to get a sense for just how revved up your soil microbiology is. So these can complement the kind of the core part of the soil testing and the records. This project is growing rapidly. We started it in the fall of 2016 with 12 vegetable farmers, and this past fall, we worked with 59 farms across the state, including 36 vegetable farms, 15 row crop farms, and 8 grazing dairies. We're very fortunate to have received this past summer a 3-year grant from the NRCS Conservation Innovation Grants Program, and we plan to be growing our benchmark network to 150 farms over the next 2 years. I mentioned kind of the core piece of this is the soil sampling and the Cornell Soil Health Test. Some of you may be familiar with the Cornell Soil Health Test. Some of you may not be. I think it is a really valuable and innovative tool for looking holistically at soil health. And it has a number of indicators involved in the test that really span the kind of the 3 prongs of soil health. So looking at chemical fertility and chemical soil health, some of the things that you might be most familiar with from traditional soil testing, but also some measurements of the physical health and structure of the soil, as well as a more detailed look at the biological health and life in the soil. The package we work with Cornell has 11 different indicators that it returns as part of the package. And these span physical indicators, so we get a read on the soil texture, your essential reading as to the soil's composition of sand, silt, and clay particles. We look at the available water capacity, which is a measurement of how much plant available water the soil can hold. Certainly very important as we think about managing for more extreme precipitation patterns, short-term droughts, as well as deluges. We measure aggregate stability, which is an index of how well soil particles can hold up to disturbances like extreme downpours. This is a really important indicator for physical soil structure and the ability to resist erosion and so forth. A number of biological indicators in the test. Of course, organic matter, the kind of the central engine of biology and biological soil health. We look at soil protein, which is an indicator of the nitrogen that is banked in organic matter. So it's a measurement of how much kind of short and long-term nitrogen supply you have stored in a soil's organic matter. We get a reading for soil respiration, which tells you something about how active a soil's microbial community is and how quickly it can break down organic materials and mobilize nutrients to plants. And then we look at something called active carbon, which is the fraction of organic matter that is easily decomposable and readily accessible to soil organisms. So it's kind of the starch and sugar of soil organic matter, and is a really useful leading indicator of where kind of the slow change organic matter pools in the soil might be going. A high active carbon reading is a good way to know that you're successfully building up organic matter for the long term. And then, of course, there's kind of some of the more classic chemical indicators in the test: pH, phosphorus concentrations, potassium, excuse me, and several minor nutrients: magnesium, manganese, iron, and zinc. And there's certainly the option to add additional minor nutrients to the package if that's something that individual users are interested in. One of the things that I think is quite valuable about the Cornell Soil Health Test is that they give you a very nice and easy to read report for these different indicators. They tell you not only the reading in terms of the raw measured units, for instance, the percent organic matter or the parts per million of phosphorus, but they also rate these measurements on a curve, on a 0 to 100 scale, and tell you a little bit more intuitively whether your soil is in kind of the optimal excellent category or having a serious constraint. And one of the really useful things about these scoring functions is that they're developed separately for different soil textures. So for the basic soil texture classes of fine, coarse, or medium grain soils, Cornell looks at its large database of all the different samples, and these scoring functions are actually telling you in terms of a percentile where your sample is on that 0 to 100 scale, basically meaning the very high soils are the 80th and above percentile in terms of performance. So that's the Cornell Soil Health Test. One of the big resources that we return to farmers participating in this project is a really detailed benchmark report. So I mentioned we collect the soil data as well as the management data, and we return a number of indicators and then show each farmer how their system is comparing relative to peer farms. So here's an example from the 2017 study. We have an indicator we call the days of living cover, and it's basically based on the farmer's information on their crop rotation and their cover cropping practices, a metric of how many days of the year do they have green living vegetation in their field. And so in this chart here, we see this particular vegetable farmer relative to their peer cohort of that year, it was 24 other vegetable farms, is actually very much a leader in terms of cover cropping. They've got some some pretty innovative practices and are hitting upwards of 300 days a year with living cover. And then what's really powerful about this is now we have this spectrum of different farms and can pull out, examples of what makes the high-performing farms so high-performing relative to some of the lower-performing farms. So we have in this spectrum farms that are just starting to really think about cover cropping and may still have bare winter fallows in a lot of cases, versus farmers that work in full-season cover crops as part of their rotation, or inter-rowing cover crops, or just have a really dedicated practice of always successfully following a cover crop to a cash crop. Likewise, we look at another indicator of tillage. We take each implement that a farmer tells us they use in a particular field, and we use a model that the NRCS has developed called the STIR index, which is basically a rating of how intensely that implement disturbs the soil, ranging from a very high disturbance implement like a moldboard plow where the soil is inverted down to 6 or 8 inches, versus something which really has a much smaller disturbance like a grain drill, just really compaction and maybe some very localized disturbance of the soil. And we total that up on each field and can look at how different farms compare. And so in this example, this farm was also kind of a leader in tillage and has some pretty intensive practices in tillage relative to their peers. But we're able to pull out from our data, what these different cases are and what different farmers are doing. So in the high end, we're seeing multiple passes with a moldboard and a disc and a cultivator over the course of the season. At the opposite spectrum, we have some very intensive farms that have permanent bed structures and using a lot of hand tools, essentially getting down to a very low tillage system. And then in between, we had mid to large scale farms that are figuring out how to do primary tillage pretty infrequently, maybe every other year or something like that, and are really driving down the intensity of their tillage incrementally while maintaining effective weed management. And so again, the really exciting part about this project is now that we have all these data and we have all these cases, we can get these farmers together and have detailed practical discussions about what's working with respect to cover cropping, what's working with respect to reducing tillage, what's working with respect to managing reliance on different amendments, and have a practical data-driven conversation. We just had a round of these at the Lancaster Farm and Home Center this past Wednesday for project participants. And our next step will be distilling a lot of that learning into some case studies that really show on specific farms what those farms are doing to manage soil health and what their challenges are moving forward. We ran a set of these last year, which you can find up on our website. And we'll be putting out some more, again, based on that Lancaster conversation in the spring and summer months coming up here. And then one more product that we provide for the participating farmers and for kind of PASA members more broadly is we're working on infographics that really concisely sum up what our farmers are doing, are accomplishing for soil health. And so with the 2017 data last year, I don't have the most recent version of this, but for the 2017 data at least, we found that overall our farmers were doing some pretty impressive things for soil health. So the 3 key indicators here, we found that the median days of living cover was 240 days. And just to put that in context, a corn and soybean rotation in Pennsylvania without any cover crops would only be 156 days. So that's a lot more time where the soil is covered, where it is fixing carbon and building organic matter, where it's protecting against wind and rain and erosion. We found that PASA farms showed an average organic matter of 4.1% on soil types that were rated by the NRCS to have an expected organic matter of 2.5%. So that's quite a big jump and quite a big service for providing fertility, storing carbon, processing and filtering clean water. So a lot of great work there. And then we found our farms had an overall soil health score in Cornell's system of 80. And again, those scores are curved, are rated on a curve where the average is technically a 50. So PASA farms are on general doing quite well in terms of a comprehensive look at soil health. And what we're working on is making, each farm an annual scorecard like this, customized for their farms. And it's something that can be placed in a CSA box or up on a social media site or shared with a wholesaler to really provide some validation and some robust evidence of all the great work that that farm is doing to keep soils healthy and work towards long-term sustainability. Here it is now in March. We are getting ready to add new farms into the project to help farms get set up for record keeping through this season, and then work with them in October for sampling and analysis of their information. With the project growing as fast as it has, we have kind of been adapting our strategy recently, and we're introducing 2 tiers of participation for the project. And so the first tier would be more of a citizen science approach, where basically any farm or any landowner that's interested in soil health, we're happy to work with you and consult on a sampling strategy, but then we would invite you to submit your own samples to the Cornell Soil Health Lab and share your report that you get from Cornell with PASA. And we'd be happy to help you compare your results to our PASA benchmarks, as well as to invite you to any project events and share project data. The second tier would really be for our cohorts of vegetable, row crop, and grazing farms. And we're trying to grow each of those cohorts with certain amount of balance in each size. And so that would be a more kind of rigorous level of participation in the project, where we would help with cost share for 3 Cornell Soil Health Lab tests on selected fields. We would work with you to collect all the management records and organize them, and develop a personalized benchmark report and infographic. And of course, invite you to join in any project events and share project resources. So for folks on the webinar, or if you have friends or colleagues that might be interested in participating in either of these tiers, really welcome your interest. I'll wrap up here at the end with some specific information about how to get involved and how to let us know you'd like to be involved. Okay, so coming up to the home stretch here, this is kind of the exciting part for me as a scientist, starting to look at the data that we're coming in through this project. I think one of the great things about doing research on commercial farms, is the capacity to be surprised by data, to see data from new contexts and in new situations. And we're certainly seeing that with this project. This chart shows you for our 3 different farm types, the grazing dairies, there, the red circles, the row crops, the green triangles, and the veggie farms, the blue crosses. The relationship between the organic matter rating, again, kind of a central measurement of soil health, biological soil health, and tillage intensity on the x-axis. And so we found that certainly our row crop farms, a lot of them are no-till farms. Many of them have really excellent organic matter scores. Our grazing dairies, almost across the board, it had fantastic organic matter. But we also found a lot of situations where organic vegetable farms were maintaining high organic matter while also practicing some pretty intense tillage. And so this is a really interesting result, kind of a controversial result. It points to the capacity of organic farmers that are really working with cover crops well, working with organic inputs well, to manage, at least in some cases, the kind of the soil disturbing aspect of tillage and weed management with organic matter maintenance and soil health maintenance. But we do see a kind of a negative relationship between that tillage index and aggregate stability, which is that one key measurement of physical soil health, of the ability of the soil to withstand disturbance and rainstorms and so forth, where that, as you might expect, tends to be somewhat negatively correlated with more intense tillage. And so that's something definitely to look at, certainly a motivation for always being very thoughtful and trying to reduce tillage even in organic operations. We find that on different farms, we see different challenges. So in this graphic here, we're looking at the organic matter rating, again, from the constrained levels all the way up to the optimal for our three main cohorts. Each dot here is a different field. The blue dots are the median. And we found that most of our farms had optimal organic matter, although there are some cases of less than optimal or even maybe a little bit low in vegetable systems, somewhat less so in the row cropping systems. And then pretty much across the board, as you might expect, we see phenomenal organic matter levels in the perennial grazing systems. Aggregate stability, as I mentioned, tends to be a real challenge, especially on vegetable farms. Most of the farms we measured this year, the vegetable farms, had low aggregate stability, some with really problematic measurements, although more than a few cases of excellent to optimal organic matter, aggregate stability. A similar pattern, but less so, I would say, with the row crop farms. And then again, grazing dairies, those perennial systems tended to have optimal or near optimal aggregate stability. And then looking at phosphorus can be a particularly challenging chemical aspect of soil health, particularly in the Northeast. We found that the median values in all systems tended to be optimal, but we do see a lot of cases of very low phosphorus scores in vegetable and row crop farms. This is a little tricky because you can get a low phosphorus score in the Cornell system by having excess phosphorus levels. And that's typically what's going on here, particularly in organic vegetables. A lot of farms will get into situations where they become a little too reliant on off-farm manure or compost for fertility and end up bringing in a lot of excess phosphorus. And that becomes a real constraint, potentially an environmental hazard, as well as potentially a plant health and nutrition hazard. Found it was much less common on the grazing dairies, and it's actually pretty remarkable for the dairy industry to see such optimal phosphorus scores. It points to the fact that many of these dairies are largely closed loop systems where there isn't a lot of feed or fertilizer being brought in, and the animals are being raised on local grass, and we have, as a result, nearly optimal phosphorus scores. One of the super exciting things about this project is we're starting to build a time series, a real longitudinal look at soil health on our member farms. I mentioned we have funding through the next 3 years, but are working actively to hopefully set up a much longer term look at soil health and make this project as permanent as we can. But just looking over the last 2 years, you can get some really important perspective on how dynamic different soil properties are and some of the challenges that different years can bring. And so for instance, this is a look at aggregate stability from 2017 to 2018 on just the vegetable farms, excuse me. And we found that pretty much across the board, aggregate stability crashed this year. We had, mainly excellent to optimal measurements in 2017, and very low aggregate stability measurements on many vegetable farms this past year. And I'm thinking that is largely a function of the weather, of a lot of very intense rainstorms throughout the year that can have some cascading effects where farmers get pressed for time and are bringing machinery onto fields that are maybe a little bit too wet to work. And that really has a very immediate and measurable impact on the aggregate stability of the soil. But the good news is that we did not see that drop in organic matter rating. And so most farms only declined a little bit in terms of their organic matter. That tended to stay stable across the years. Organic matter is certainly a much slower change variable. It's also kind of the source and the engine for aggregate stability. So it points to a lot of potential moving forward into 2019 with better weather, hopefully, the ability to rebuild this dimension of soil health, rebuild the aggregate stability. So that's really exciting stuff. Couple of quick questions that have come up. First, did the sample of farms change? We've grown from 12 farms in 2016 to, I believe it was 28 total in 2017, and then 59 this past year in 2018. With a few exceptions of farms that have dropped out for various reasons, we've been keeping the same farms year after year and adding new farms. So that, like I said, will enable us to build hopefully a longer term look at soil health. A question about, are we interested in adding hay farming to the study? We are interested in working with pastured livestock operations. This year, it was just grazing dairies, but we're going to expand the scope to include some beef and mixed livestock as well. And those farms usually do have some hay fields in their system that we sample, as opposed to actively grazed pastures. We probably won't be adding a cohort of just straight up hay farms anytime soon, although I would certainly welcome participation in that tier 1 level that I mentioned from any hay farms. And so on that note, just a reminder, if you'd like to get involved, if you want to participate in either tier, I think in that sort of collect your own sample tier 1 system, or think about whether you would fit into the vegetable, row crop, or livestock cohorts for the tier 2. There is a quick application on our website where we just ask a few brief questions about your farm. You can let us know there. That's the link right there. It's a little long, but very easy to find on the PASA website. Or you can also contact Sarah Nawa, our research coordinator, who is handling a lot of the outreach and communications with farmers in this project, or of course me. It's been really great to see the interest in this project grow over the past couple years, and it's only going to get more valuable as we continue to work with more farms and learn together. Yeah, so thanks very much, everyone, for your time and attention, and I'll open it up now for any further questions. So again, we have a question from Rebecca, who's asking about, they have a 4-H cooperative farm with multiple species, steers and dairies, to horses and alpacas. And they're going to be starting rotational grazing this year. Want to know if they would qualify. Yeah, I think your farm does sound like a good candidate for that pastured livestock cohort, and would like to follow up with you about that. Easiest thing would be to just fill out this quick survey on our form so we can learn a bit about your farm. really one of the minimum kind of barriers to entry are that you're able to maintain the kind of detailed records that contribute to this study. And so that would include for a grazing farm, when and where you're moving animals, the animal density, any mowing or planting operations, as well as any fertilizers or amendments added to the fields and when those happen. Okay, so a question down from Florida, someone who is moving to Florida, starting a new farm this year, and wants to know if we're only looking for farms in our region. Currently, we are kind of limited just based on our staff and geography to Pennsylvania, and probably we'll find some farms in Maryland and New York as well. But I will say that we have had some conversations with some other farm organizations in different places, in Massachusetts, in Carolina, that are interested in kind of adapting our method and feeding into the study. So one thing that could happen is if you're able to hook up with a farm group down there in Florida, a sustainable ag or organic farming group, we might be able to work with them to set up a Florida cohort if they had the time and ability. So that's one kind of option we're looking to long-term grow the reach of this approach. So we have a question about someone with a farm den, a homestead farm, and are interested in baseline data for their lands, or want to know if they're suitable for this project. And I would say that, probably in that case, we'd look for being involved in the tier 1, where we would be happy to sort of guide you on how to do the soil sampling, but have you pay for and send in the samples to Cornell. And then we'd help you see where your samples compare to our benchmarks. So the tier 1 involvement would work well in your case. So someone wants to ask that I clarify the distinction between tier 1 and tier 2. Basically our interest in the project is growing really fast, and we have a priority to kind of grow some different cohorts of the vegetable, row crop, and grazing farms, kind of focused on commercial scale farms. But we're really interested in working with whoever we can, and farmers of all different stripes and shapes. So basically the tier 1 level is more of a do-it-yourself citizen science approach, where we will consult with you on a sampling strategy, but then have you pay for and send in your own samples to Cornell Soil Health Lab. But then we're happy to share our benchmarks for you to compare against. And then tier 2 is the more kind of rigorous involvement in the project, where we will do cost share for the soil sampling, as well as work closely with the farmers to get all of the necessary management data and produce the personalized benchmark reports and infographics. So we have a question about a farmer that has multiple different practices in different locations in their valley. One is organic hay and row crop, another is continuous no-till, and another is rotationally grazed cow-calf pairs. So would we be interested in studying each of these separately to see how they compare? I would say yes, that is a pretty interesting possibility, that we would have all 3 of our farm types managed by the same farmer and could look at them that way. So I would definitely be interested in talking more with you, Kulrich, and seeing if your farm would be a good fit. We have a question about costs for the soil sampling. So we use the Cornell standard package, which is their mid-tier package. It has those 11 indicators I mentioned. You can get a more basic one, or you can get a fancier one that includes some like pathogen tests and some other things in it. The standard test is fairly expensive. It's $110 a sample. So for our 3 fields, we're talking $330 a farm. And I have heard that Cornell is working to bring their costs down, but you know, right now the reality of soil health testing, that's what the test costs. Someone asked about Penn State Extension and their testing. You know, Penn State has a great system for chemical soil health testing. You know, can certainly give you a very cost-effective package for, you know, pH and phosphorus and potassium and micronutrients. For an extra fee, they will give you organic matter, but they don't have kind of these next level soil health tests like aggregate stability, water capacity, soil protein, respiration, et cetera, as part of their mix. So the systems aren't super comparable. And just you know, an additional thought on that. The way I like to think about it is, you know, the traditional university lab soil health testing or commercial lab, or I'm sorry, soil fertility testing that you get from university labs or the commercial labs is really important part of management, especially on commercial farms. You know, something you probably want to be doing every year on your fields before developing a fertilizer plan. But it doesn't give you the kind of the long-term holistic perspective on soil health. And so Cornell is a great tool for that. It's more expensive, which is probably why, you know, doing a few fields each year or just looking at, you know, a couple fields each year through our system is a good way to get the kind of the benchmark for soil health without ballooning costs up too much. Okay, any further questions from everyone? Great. Well, here again is my contact information, that link to the study application survey. And very happy to continue talking at any time. I will, yes, someone asked, will I email the link? I will be sending out the link either this afternoon or tomorrow morning, along with the recording of this webinar. And yeah, thanks everybody for your time and for your interest.